morning, बच्चों. Now, today we are going to solve chapter 5.4. It is the last chapter of arithmetic progression, and we have already solved uh, all questions of 5.3 and 5.2 and 5.1. Now, this is the last chapter, so just I am finishing this chapter today. So let's see some questions which may trouble to you. So now I'm going to solve questions. Question is: a small terrace at a football ground comprised of steps, each of which steps each of which is 50-meter long and built of solid concrete and built of solid concrete. Each step has a rise of each step has a rise of 1/4 meter, 1/4 meter, and the trade-off and the half-meter. Calculate the total volume of concrete required to build the terrace. So, student, we have this question, and in this question you are looking here. Question is telling a small terrace of a football ground comprises the 15 steps. Clear? So, this time we will be making in such a way the total the distance, which means that you know that a step is in the shape of this, you might say, stairs. You have already seen in your house. The stairs are in this shape, that is divide shape. So the total length of the 15 steps, 15 stairs, total length is given here 15. Total, this is the total number of steps. Number of steps, which is n. N is given here. This is your part of question. On solving it, n is given here 15. The number of steps, the total steps, that is total steps are given here 15, and the total length, that is this is given 50 meter. The total length is given 50 meter, and the breadth of each step or stair is 1 upon 2. Breadth is half meter, and length is equal to 50 meter. Total length is given here 50 meter, and height is given here 1 upon 4 meter. Clear? This is the total number of steps, which is n is equal to 15. It is already mentioned. This total, this is n is given here 15, and the total length of the step is 50 centimeter or meter. 50 meter. Okay, it is 50, and the height is given here 1 upon 4, and the breadth is given here 1 upon 2. Each step is in the shape of this. Here, so the breadth is given. This is the breadth. Breadth is given here 1 upon 2, and the height. This is this part. This part. Height is given 1 upon 4. So you know that when you will take, when you will going, since it is in the shape of cuboid, so if you want to calculate how much concrete will be used for each step, so which means that what you want? You want to find the volume of the cuboid. Clear? Each step is in the shape of cuboid, so you will find the volume of the cuboidal shape. You will use the formula of volume of the cuboid, because each step is in the shape of cuboid. So let's start. And the total length is already given here. For the 15 step is given here 50 meter, height is 1 upon 4, and width is 1 upon 2. So let's calculate for the first step. So what you will write here? You will write here volume of the concrete required to build the first step. You will write here volume of concrete volume of concrete required to build the first step. That is step 1. So you know that volume of it is the general formula. It is the general formula. L into H, and you have length 50, breadth 1 upon 2, and height is given 1 upon 4. So this is 25 upon 4 meter. Clear? It is the volume of meter cube, not meter, meter cube. So the volume of the concrete required for the first step is for the step 1. This is the volume for the step 1. Now, you know that when this is the step 1, and now when you will move for the second step, then what will be the difference? The difference will only you will find the difference in only height, because if it is the first step, then another step will take place at over this, then another step take place at over this, second to third, third to fourth, which means that there is no difference between the length of the step, total step, and there is no difference, no changes between the height, between the width of the step. But you are looking here, only the changes are coming in the height of the step. So if it is a first, then second step will be upward. So the height will be 1/4 plus for the second 1/4, 1/4, then 1/4. Now for the fourth step 1/4, 1/4, 1/4, which means that for each step, you are looking for the second step, you will see the difference in height. Height will be 1/4 plus 1/4, which means that 2/4, which is equal to 1/2. If I am multiplying 2 in this form, if I am multiplying 2 in the first step, then the total, there is no difference for the volume of the concrete. But for the second step, the height will only increase. Height is increasing, so 1/4, 1/4. So I am writing here volume is same, but only difference is in the height. So for the second step, calculate volume of concrete required to build the second step is equal to L is equal to 15, B is equal to 1/2, that is grid, and the height is making the difference, that is 1/4 plus 1/4. So 2 into 1/4. Then just removing the part of the question, just do it from here. So from here is equal to 50 multiplied by 1 upon 2 into 1 upon 4 plus 1 upon 4. That is 25 multiplied by 1 upon 4 into 2. Here, which means that 25 upon 4 into 2 meter cube. This is for the second step. Clear? Now for the third step. Now for the third step. L into B into H, the same thing. L is 50, width is 1 upon 2, and height is 1 upon 4, 1 upon 4 plus 1 upon 4. That is 25 upon 4 multiplied by 3 meter cube. Clear? So in this situation you are looking here. This is the volume for the first step. You may also write here multiplied by 1. The volume is required to make make a stair or make a step, which means that volume of the concrete required to build a step, build a stair, that is which is in the shape of cuboid. So you are using here the formula of cuboid, volume of the cuboid, it is L into B into H. So in this situation you are looking the volume, total volume required for the first step, it is 25.4 meter cube. Clear? Now for the second step, you know that when the height and the length are same, but increment is in the height. It is finding the increment in the height. When one step is here and second step will be built over to first step, then height will be just double. So 1 upon 4 plus 1 upon 4, that is 2 upon 4 are equal to 1 upon 2. So just it is written here, and for the second step this is this, and for the third step this is this. So arithmetic progression forms for volume of concrete required to build steps. And arithmetic progression is here 25 upon 4 into 1, 25 upon 4 into 2, 25 upon 4 into 3, up to so on for the 15 steps. So it will be for the 15 step 25 upon 4 into 15. That will be the volume. That will be the arithmetic progression. So you are looking here, these solutions are forming an arithmetic progression which is 25.4 into 1. 1 for the step 1. So 25.4 for second step, 25.4 for the third step. This is the volume. This volume which is required to build a step or the stair. So for the volume we are creating an arithmetic expression, arithmetic progression which is written in this form. Now 17, total steps or the stairs is equal to 15. It is already mentioned in the question. This is equal to n. This is equal to n. Now, in this situation, Sn is equal to n by 2 2a plus n minus 1 into d. You want to find the total volume which is required to get the 15 steps. So the total volume which will be calculated by Sn. Clear? So in this situation, you are looking here. You are looking here. A is equal to 25 upon 4. This is your first step. And first term, not first step. This is the term 1. This is term 2. And the second term is 25 upon 4 into 2, which is equal to 2. So this is equal to 25 upon 2. This is the second. A2, A1 is equal to 25 upon 4 and A2 is equal to 25 upon 4 into 2. So 2, A2 is equal to, you are finding 25 by 2. Therefore, D is equal to, you know that A2 minus A1, therefore D is equal to 25 upon 2 minus 25 upon 4. Now calculate this. You will find 25 upon 4. You have to start calculating it. Now, D is equal to, after calculating this is the calculation part. You are getting 25 upon 4. After calculating this D, you are getting a 25 upon 4. Clear? So, put all these values in the formula. So, S 15 by 2, 2 into 25 upon 4 plus 15 minus 1 and 25 upon 4. This. So S 15 is equal to 15 by 2 15 So the total volume is equal to 750 meter cube. So total volume of concrete to build the 15 steps 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 is equal to 750 meter cube is equal to 750 meter cube. This is your required result. Clear? So in this way, you will solve this question. Now, another question. Now let's see another question. A ladder has rungs 25 centimeter apart. A ladder has rungs 25 centimeter apart. The rungs decrease uniformly. The uniformly uniformly sorry uniformly in the length of in length from in length from 45 centimeter to 45 centimeter at bottom to 25 centimeter top, and the bottom range are and the are 2 whole 1.2 meter apart apart, which is the length of the wood required for the rungs. So let's see here. In this way, a ladder is given, which is 55 centimeter, and the total length of the ladder is given 1 to 1.2 meter, that is equal to 5 upon which is equal to 5 upon 2 meter, or 5 multiplied by on 2, which is 250 centimeter. So the height of the ladder is given here to hold on upon 2 meter. Now we have converted this meter into centimeter. So when we will multiply 100, then it is the 250 centimeter. The total length is given here 250 centimeter of ladder. Now again, it is given here the distance between the rungs is 25 centimeter, and the last, which is top, the top rung breadth is 25 centimeter, and the distance between two rungs is given here 25 centimeter, because at the bottom level it is 45. Now when it comes, it is going upward. The rungs are uniformly decreasing. So after decreasing, the toppest, so the topmost rungs is 25 centimeter, and the bottommost is 45 centimeter, and the difference between the two rungs is given here 25 centimeter. So what you want to find, what is the length of the wood required for the rung? So you want to find the length of the wood. Clear? So what you will write here? You will write here now. Let's see. Distance between, which is the solution. Distance between two rungs is 25 centimeter, which is written here. Now, so number of rungs is equal to 250, the total so the number of runs required. So what will be the number of rungs? Number of runs, it is given in the hint in the question. The number of runs are 250 upon 25 plus 1. It is already given in the question. So just we have used here the total number of runs are 11. It is your number of runs. Here. Now length of the first rung, that is bottom, is equal to 45 centimeter. It is already mentioned here. So length of 11 rung, that is topmost, is equal to 25 centimeter. You have calculated the number of rungs are calculated 11, and in the question it is given here the bottom level rung is given here 45, and the topmost is given here 25, which means if the total number of rungs are 11, then the topmost rung height will be 20, length only, height, not height, length. So topmost rung length will be 25 because it is the last, and total rungs we have calculated here 11. So this is the last one, and which is 11th rung, and the total length is 25 and the bottom level is 45, and the difference between two rungs are 25 centimeters. It is already mentioned in the question. Now let's start calculating. We have to suppose that, consider it, to make an arithmetic solution, you have to just calculate what's up. Let the length of each successive rung be x centimeter. Just now we are considering. So total length of the rung will be 45 centimeter plus 45 minus x plus 45 minus 2x up to the last, which is 25. Last, which is 25. So arithmetic progression for this is equal to 45 minus x, 45 minus 2x up to 25. Clear? Now A is equal to 25. The last term L is equal to 25, and the D N is equal to number of terms are 11, and the D is not required. Now use the some formula. S N is equal to N by 2 K plus L. So just we are considering if the length of the each successive rung bx. Okay. Now the total length of the rung will be, what will be the total length of the rung? 45 from the bottom plus 45 minus x, next level, then 45 minus 2x, then next level, then 45 minus 3x, next level, up to 11th term. 11th, that is the last, which is last, and the value of the last 11th term length is given here. The length of 11th step or the 11th rung is given here 25. So it will be start from the 45 from the bottom. Sorry, it will start from the bottom, which is 45, and it will go up to top level, that is 25. This is the 11th term, and this is the first step. and this is the last step, which is 11th step, because the total length we have calculated here. Total runs are in the ladder is the total runs are in the ladder are 11. Only we have calculated it. Number of runs are total 11, and the bottom level is 45, and the topmost level is length of the topmost rung, which is 11th rung. Total length is given here 25 for the topmost, and the total length for the bottom level is 45. So the total length of the rung, total length which is required to make the each one rung. So the total length will be calculated as 45 plus 45 minus x, 45 minus 2x, up to 25. Here, so in this situation, this is forming an arithmetic progression, which is it is the last first A1, it is A2, A3, and this is A11. A11, that is the last turn, and the number of turns are 11, and it is the last turn. So last turn is 25, that is an is equal to 25, number of turns are 11, so just calculate it as n is equal to 11 by 2. A is 25 plus 25, which is 11 by 2, 50. Clear. So I'm clear. So what we have done? Okay. Sorry. It is the first step. It is 45, not 25. Is equal to 45. Okay. It will also be mistake here. Now it is 70. So 35. So the answer is 385. So students, this is all out for the arithmetic progression. We have already solved many questions, and now today I will finish this chapter. It was the last chapter, 5.4. Now next time we will discuss coordinate geometry. So thank you.